So let's start with the explanation for the tutorial of this question. Uh, So what I thought of this question was like in this question, what the problem is saying is we are given a matrix of m cross n size and initially it has all zeros. Then we are given queries in this ops that will make it plus one in all the entire range of the ops. So like first this one would be increased by plus one, and then we have another query that is of size 3 by 3. So when we will apply 1 plus 1 over entire this, so this portion will become 2. So we have to return the maximum integer, like 2 is the max integer and its frequency is 4 in this binary matrix. So the approach that I took in this was initially I got the correct approach only. I thought of the correct approach only. I took the answer initially to be the m star n. Like initially, if no ops were given, then entire this would have zeros would have a max frequency of that will be equal to m cross n. So I took that, and I took the a cross b product, like in the a cross b, what is the maximum of that, like the minimum of the product, because that will be the counted the maximum times. But this is not the right intersection method. The right intersection was like initially I took the answer as m star n, and if the length of ops was zero, like these operations were zero, then we have to return it the entire m star n because of no no update thing. So zero has the maximum frequency that is equal to m star n, and I took another thing, minimum a, that will calculate the minimum of the row length, and minimum b that will calculate the minimum of the column width. So for each of them, I calculated the minimum of a, minimum of b. So this way, it was able to fill it. Like to explain this, like initially I had a matrix like this. This, let's say this was the matrix. And let's suppose in the first query, we are updating it through this. So, and in the second query, what we are doing is we are updating it via this. And in the third query, what we are doing is we are updating it like this. So based on this portion has the maximum coloring because it is getting input from this red color also and the green color also. So based on this portion has the maximum coloring because it is getting input from this red color also and the green color also. So what I'm thinking of now is the brute force approach was initially taking a temp array, then for all the row and column in ops, for each of them we are increasing the temp by +1. So this approach was one of that. But this was a very long ass approach and I have to take so many counters and all that thing. So this brute force approach has been like given here in a cleaner form. So the main entire crux was like taking the minimum of A and minimum of B because of the like the intersection point of the columns and the rows that will be in the intersection point. Let's look at another question. So this problem was also similar to the previous problem, but like in this one also, it's like we have to we have to calculate the maximum area of a piece that is cut by horizontal cuts and the vertical cuts. So in this problem, what happening is like we are given a grid and we are given a array that represents the indices at which we are marking some cuts horizontally or the vertically. So the maximum area that is being cut by any of that will be the consecutive difference between two, like the maximum height of this would be equal to the consecutive difference between any two horizontal cuts will give us the height of this block, and the max of these two consecutive vertical cuts will give us the width of the box. So what I did was there was a mod thing that was being asked in this question, and
नीचे चल थोड़ी देर दो सारे बच्चे बाहर घूम नहीं जाते तू भी आ जा देख रहा अभी
So as said, it's based on the horizontal cut and the vertical cut thing. So the trick here was appending this zeroth and the edge in the horizontal cuts and the vertical cuts. This will what this was helping is like it's helping in the first cut and the second first cut and the like the boundary cuts also, because them points can also be the part of the cutted cake. Like this portion can also be the answer, but we are given cuts this only, we have to consider these as the boundary points also. So what I took was maximum consecutive difference between any two cuts will be minimum equal to 1, and for I in range every consecutive cut I took the max and then I multiplied it to get the area. So in a more Pythonic form, uh, what was happening is I took the sorted array cuts because sorted because in the example 2 there is this thing, like in the example 2 they have given horizontal cuts in 3:1 form, but that is not the that will not help in the cuts thing. So this way I was able to get the cut and max h I have calculated for the zip wise in h of cuts and h of cuts 1 till end. This way it will a and b will be the consecutive next current in the next cuts of the cuts array. So this way we have calculated the cuts in one of these. So this was this entire problem. And coming at this problem is also quite similar. What this problem is saying is like that we are given a wall of bricks, and we have to find a vertical line that passes through minimum number of bricks, like, and each edge won't be counted as a brick. So let's say if a line passes through this line, So this one will consider passing through the entire 1, 2, 3, 4, 6 bricks. Let's look at this one. This one would cut only this, and this. So this will have only 3 bricks that are being broken through this way. And let's consider this point. This point will have 5, and this one will be left out. Let's consider this one. This one will have 3 edges and 3 bricks. And let's consider this one. This one has only 2 bricks. This one and this one that is being broken. These two are edges and these two are also edges. So they won't affect the shit. These two are also edges. So they won't affect the shit. So what next is like these 3 problems are quite similar that we have done previously. And like the crux in this problem is we don't want to minimize the number of bricks that we are passing by. The crux is we have to maximize the number of edges that are being on that crossing line. So we don't want to count the bricks. We want to place line where it crosses the minimum number of bricks that will have the thing where it will pass through the maximum number of edges. And the line passing through edges between 2 consecutive bricks does not cut a brick. Yeah. So instead of counting bricks and minimizing for the bricks that are being passed through the line, we have to maximize the number of edges that are being crossed by the sweeping line. So the best portion for the answer would be where the maximum edges align. Like in this one, these 2 edges are aligning and these 2 edges are aligning. So 4 edges are aligning, and thus this line will give us the answer. So I have counted default dictionary for every row in the wall that will represent bricks. Position is initially 0. And we have to skip the last brick because it is on the boundary, and this will definitely be the answer because the maximum number of edges are aligning in the boundary. So we are going till for every row till very end only. Like let's look at this example. We are given bricks of size 1, 2, 2, 1. So there would be an edge at index 1. There would be an edge at index 3. There would be an edge at index 5, and there would be edge and index 6. And each of these rows will sum up to 6 because the width of this is 6. So what I am doing is like for every row I am counting all the edges position. I'm storing that in the dictionary, and at every position it's counting like how many edges are aligning. So when the position is, let's say, 1, so at index 1 3 edges are found. So the dictionary will this dictionary edge count will store something like 1 semicolon 3. And at this point also, like this point, it will store 2 comma 2 is to 1. So it will look something like at position 1 there are 3, then at position 2 there will be like one only one edge. Similarly, at position 3, that will be at index 2, there will be 2 edges in this. And similarly, at this position, that is 4, we have 4 edges, these two and these two. And at position 5, we have 2 edges. And at 6, it will count all these 6 edges, but we will exclude it in the answer because it is at the very end. So this won't count. And like if there was no edge count, we just straight simply return n, because this was a single brick thing and we have to cross everything. And that's the max of the dictionary, and we have to return n minus max number of edges that was found in a single sweeping line. So this was the solution for this problem, and these 3 problems were kind of similar. So let's come at this editorial for this question. Let's review it, which I solved yesterday. So in this problem, like we are given a grid that will have some numbers inside it, and we have to find the length of the longest increasing path in that matrix. Like yeah, like this is 1, the next increasing thing here is 2, then here is 6, then here is 9. So more than 9 we don't have any. So that's the maximum path. Let's say if we started at 6, then we could have gone at 8. We have to stop here only, or maybe we could have gone above directly. So this length is 2, this is 2. Basically it's like the r comma c thing. problem only that we do usually. So the solution is it's the length and the number of columns and the number of rows. And I have defined a DFS that is taking an input as R comma C. R comma C. And like the basic crux idea is we are gonna start start the DFS at every point and count the max, store the max of the length of the path that was found. So this one will take care of calling DFS at each point and returning the maximum path that is being found. So now let's look at the DFS code. DFS code takes the R and C coordinates of the starting point of the DFS, and it keeps a counter variable, and it initializes it with one because initially the number of element in the DFS will be one, and then it's taking dr comma dc in that directions array, up, left, down, right, and these are the nrnc, that is a new row, new column coordinate, that will be r plus dr, that is the change, and c plus gc, that is the change in c. So first I have put a condition of the out of bounds thing, like these point cannot go out of the boundary, like 0 to n the row should stay, and 0 to m the new column should stay. And yeah, this is the main entire crux that is being guiding to where to move the next DFS call. Like we can only move when the next value of the grid cell is greater than the our current grid cell's value. Like the grid cell of new row, new column should be greater than the grid of the original row and column point. And I have taken a count that will count the maximum of the path length that is being traversed by the DFS. So it will be max of count and 1 plus calling the next DFS for that next point. And yeah, so this will give TLE. So I have used like the basic thing was using the normal cache only. This will take care of the DP thing, but the manual memoization we can do by taking DP as a dictionary. And if this tuple of row comma column is in DP, then we will just simply return it. Let's say uh, the the traversal in the this one, it would have started something like this. It would have went this way, this way. So for this 6, it would have stored the path length as 2, because of from 6 we can go maximum till 2, only because only the 9 is the only greater element that is in neighborhood of 6. So when the call would have came for this one would have asked like it would have went to 2, then it would have asked like from 2 what was the maximum length we would have traveled. So it would have been stored because this 2 was filled before to this 1 point. So this 2 will return as 3. So the max will be like the current one. So 1 plus here would be 3. And this value DFS of this portion, this The nr comma nc will be this, r comma c was this. So it would have been the value as 3. So max of 1 and 1 plus 3, that's 4. So answer would have been 4 for this one. And here, this is just the storing part of the memorization thing only. So this was the editorial for this question. We have solved this is a very standard problem. R comma C we take in graph problems in like the BFS and DFS thing mostly. And here we don't need a visited array like we usually do in yeah. So this was the tutorial for this problem. And this one. So what this problem is all about is like we have to calculate the XOR range and multiplication. So we are given a nums array, and we would have been given a queries array. So what this query, each query will be of size 4. So what this will represent is L comma R, that is the initial starting point and the ending point of that interval, and it's the step like from 0 to 2. So 0, 1 and 2, and we are taking a step of 1 because the step value is 1 only here. Like wait. So 0 to 1 is the interval, that 0 to 2 that we are looking for. So the points that will come is 0, 1 and 2, and the gap is of 1. Yes, so the gap here is of 1 in this one, 1 till 4, and the gap is 2. So first we will take a 1, then the gap would be of 2 places, so it will become 3, and then that's it. In this one, it will go completely till 0, 1 and 2. So for every query in queries array that we are given, L comma R comma step would be the first point, second point, and the third point, and the multiplier would be this one. So at index 0, 1 and 2, we have to multiply it with 4, so it will become 4, 4, and again 4. Taking XOR of all of them, give us 4, so answer is 4. And like processing this first query at in the range 1 till 4 and a gap of 2, multiplying it with 3. So the points indexes that will come as 1, then adding 2 that will come as 3, then 4 limit has been reached, so we won't go there. So it will become 6, and this point, third index, we have to also multiply. Wait, this will become 9, and this will become 15. Yes, 9 and 15. And the next query is 0 to till 2. So 0, 1, and 2, and multiplying it with 2. So multiplying this point, and this point with 2. So these 3 points, 2 will become 18, 2 will become 4, 9 will become 18, and 1 will become 2. So this is the final array, 4, 18, and this. So ZOR is 31. That's the answer for this one. And now let's look at the this problem also. This was today's POTD, but I have already solved it. So we just have to look at the answer. So what this problem is all about is minimum distance between three equal elements. So we are given an array nums, and we have to calculate the distance between 3 points that will have the same value, nums value, and the distance is absolute of the indices difference. So like in this one, there are 3 points, 1, 1, 1. So this distance is 2, this distance is 3, and this distance is 1. So 2 plus 3 plus 1, that 6 is the answer for this one. And in this one, we have these points. So the distances would be this, this, and this. Another points of 3 points with that we have is these. So the summation of these three distances and these three. So I think like 2 and 2, that's 4 and 8. 1 and Yeah, this is 1 and this is 4. So 1 plus 4 plus 5, above 1 will give 10 and this is giving 8. So answer is this. So the idea is simple. Initially we have taken it as infinity, and we have taken three loops I, j, k, and each one would be after the another one, like j would be greater than I and k would be greater than j. If these points are similar, then only we will calculate the dist, and dist is calculated at this and answer will be minimized. If, like, we will return -1 if we were not able to find the answer. And what I'm looking is here is we just have to calculate the only the first and the last point of finding of that number. So that will be part 2. So in part 2, what we are doing is it's the same question, just that the constraint are increased to 10 power 5, and here the constraint were only 100. So a triple loop was working. In this one, we are using a position dictionary that will store every index at which a number would appear. Like for I comma num in enumerate nums, if it's not in position, then we will create a empty dictionary and add it. So this will fill up. Like for the num 1, indexes are, it will look something like this. For the num1, indices are 0, 2 and 3. And then for num2, the indices are 1. For num3, the indices are 4. So for every value in position, like the 1, this would be the array of that position. And we are having a sliding window of size 3 that will go till length of array -2, and distance will be twice of that sliding window. Yes, we will return it. Another approach is expanding approach. This will TLE. This is a big of n square approach only. Like we use the expanding approach in the palindrome thing. What the idea would be is like this won't work. This is the expanding approach idea. This one is simple. Now let's coming back to the this problem. 1260 shaped grids. What this problem is saying is we have to perform the operation k times and shift every element to its next one. And if it's in the boundary position, this will go here. And if it's in the last position, this will go up directly here. This one will go here. This one go here. This one will go here. This one go here. This one go here. This one will go here. This one go here. This one go. So the simple brute force solution was we are applying the loop k times as being asked, and we are storing the each of the row, like the entire thing we are storing before every iteration of k. In entire row is copied and for row entered. Yeah. So what this is doing is for each I comma j in that column, if I is if j is m minus 1, if it's on the column and I is not equal to n minus 1, I plus 1 is less than n, so I is less than n minus 1. So like this portion, if it's in this portion, this would do like this. You're getting in the next row for the first element. Grid of I plus 1 and 0 will become original of I minus 1 and j. If I is also n minus 1, if it was the position, then it would straight up become this one, 0 comma 0. And else I comma j plus 1 will be ij. This position will be this. Now let's look at better approach. I guess now the lag is not there. After I have removed the iPad screen, then maybe this will help. Who knows? So coming at the better approach, this will be the number of elements totally in this one. And each one of them would be added plus k times and then modded up by this n. For like I have to build a flatted iterator. Yes, this has done making the These are coming out to be same. Ith coordinate will be index modulo k. Modulo total number of n. Like this one is 4. Index plus one comma one. That this is 0 comma 1. Is 1 comma 1 point. 1 into m, I into m plus j. J is 0. I is 1, j is 0. Yes, this one is the solution, but it's taking a lot of space. What I have done is I have for this one, I have initially filled up the flattened grid. This is the flattened grid, and this will be the rest that will be after cyclic shifting k positions. After I have cyclically shifted k positions, then it would have become better. So after cyclic shifting position, this would have become like this. Now I just have to fill it in this format. This is the answer array. Yes, this is the thing. Now let's try to write it cleaner. We would need this temp thing. Why is it in this color? this one is taking space of